Okay, welcome to this Math Bay video of a couple more tree on a hill problems at the request of one of my students. This first one says a tree is standing vertical on a hill that's sloping up at 10 degrees. So I'm going to draw my hill sloping up at 10 degrees and my very tall skinny tree, just for purposes of making this easier to solve. I'll pretend it's some kind of evergreen. The tree casts a shadow downhill, so the shadow goes down the hill and is 12 feet long when the angle of the elevation to the sun is 72 degrees. Okay, that means the angle from here up to here, that entire angle of elevation to the sun is 72 degrees, because the definition of angle of elevation is from the horizontal. So the sun is up here somewhere, shining down with all of its rays. Okay. How tall is the tree to the nearest foot? Okay. So at this point, you want to make sure you have a nice big triangle to work with. All right, if we zoom in on this just a little bit so you can see how all the angles work out in this triangle. If this is 10, and this is 10, which means this is 62. And this is 12. Well, we need this angle because we need an angle opposite a side. And we're asked to find the height of the tree. We have the angle opposite that side. So we're kind of getting close to being ready. Sine of 62 over x equals sine of this angle up here over 12. The whole work in the law of sines is all about figuring out what this top angle is. So that means I need to get this angle. There's no way I can get the top angle unless I have this one. There's a couple of different ways to do it. One of my favorite ways is to draw another line, and we have another 10-degree corresponding angle, which corresponds to this one and this one. All three of these are corresponding angles because the horizontal lines are all parallel, which means this angle is 10 degrees as well because they're vertical angles. And this angle is 90 because horizontal lines and vertical trees on a hill make a 90-degree angle, which means this entire angle is 110 degrees. Now I can get the third angle, the triangle, by taking 180, subtracting 110, and subtracting 62 degrees. Well, that adds up to 172, which means this angle is 8 degrees. I have what I need to finish my law of sines and solve for the height of the tree. So I will get my calculator here, clear out everything old. I'll do 12 times sine of 62, 12 sine of 62, and then I will divide it by the sine of 8 to get what x is. I get 76.13. Says to the nearest foot, so we're going to say the tree is about 76 feet tall. And there we go. Worth mentioning, another way to get that angle inside the triangle, you'll notice if you extend this out, it makes a little tiny right triangle here, okay, in which this is 90 degrees, okay, and this angle of 72 with the 10 and 62 together corresponds to this angle of 72. So if you have 90 right here and 72, this also has to be 8 degrees. You can get it another way, and that's what some of the students do. All right, let's do one more where the shadow is not cast downhill, but the shadow is cast uphill. Not much difference in how you solve it. You just got to still work around and find some angles. So this is our second and last example. You might want to try it on your own. So we have a flagpole, instead of a tree this time, standing vertical on a hill that is sloping up at 13 degrees. The flagpole is casting a shadow uphill of 15 feet, when the angle of elevation to the sun is 63 degrees, how tall is the flagpole? So let's draw a nice picture here. The hill is at 13 degrees. The flagpole is casting a shadow up the hill at 15 feet long. When the angle of elevation to the sun, the sun is up here at the top. The angle of elevation to the sun is 63 degrees. I have to zoom in more on my picture here. Okay, so this angle right here is 63. Let's find out how tall the flagpole is. Okay, well, originally with our 13 degrees here, if I draw another parallel line, this angle is going to be 13, and so is this one, which means if I add together my 63 and my 13, I get an angle of 76 for this angle in the triangle. So I know I'm going to have sine of 76 over the opposite side equals sine of some angle over 15. Sine of 76 over x, sine of this angle over 15. So once again, it comes down to working around and finding the measure of this angle in our triangle. Oops. So if I draw another horizontal line, those horizontal lines at the beginning and end of the shadow are very helpful. This angle right here is a 90-degree angle, and if I take away 15 degrees, that leaves me 75 for this one. 75 and 76, and the missing angle of the triangle have to add up to 180. So I will take my calculator, and I will take, so that you can see it, 180 minus 75 minus 76. I get that the unknown angle in the triangle is 29. So I'm doing law of sines, 29 over 15, and sine of 76 over x. Cross multiply to solve. 15 times sine 76. You get about 14.5. I'll divide it by the sine of 29. I get the side, or the height of the flagpole, is about 30 feet. I solved that. So there's your two more examples of vertical things standing on a hill.